So, hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 187, and in this video we repeat something which we know a little bit but can still confuse us. And to show you what that is, I made here an example code. First of all, let's read here a little bit what I made. So I created here a class which is called name. It has variables, just these two variables, which are private. One is first name coder, and here called num5. And then I have here functions. One is a constructor, actually. This is not a function. Oops. Let's rewrite this one. Oh, let's make this one down. This one is not a function. All right, so this one is a constructor. I hope you saw it instantly instead my constructor. So this is a constructor, but important is this one is not a default constructor. We learned this. The body is doing nothing. We have an initializer. We just take here the parameter here, which is our later, where we provide an argument and then we initialize here a new name. So far, I hope you know all. And then we have here a function, and this function is one of the special functions, not a normal function. It is a static function. I hope what a static function means. It is a very special behavior. And here on the bottom, you can see I have here used already the new keyword which we learned in our last videos, which is the keyword friend. And this one is not a member function. I hope that you know this. And here is a function outside of the class, which is the print name. Here we can see it. It is a normal non-member function, which is defined and declared outside, but we made it a friend, which means this function can access now this private member when we provide here this parameter which is connected to this class. I hope so far so easy. And now let's go to this main where some strange things happen. So first of all, what is this line again? This line you should know. We have talked about it, but what is the strange thing about this line? Let's watch it from start, and we start with name. Okay, this is our class. Then we use this resolution operator, scope resolution operator here. Okay, the scope resolution operator means I go to this name and then I try to find in it this function here, which is the static function. All right, so I know. I go to this class, I go in it. Yes, it is here. So what is the problem? The problem is here, this is not the normal way, what we learned how to use a class. That's why this static function is a very special function. What was the reason for that again? Oh, let's say, what was the normal way? The normal way is actually that we create first an object for this class and then call functions. That's the normal way. Let's make an example. Let's create an object. We just use the class name, which is our type, and let's say name class, name object, just so. And you can see I can't use here this default object creation, which I used many times. Why I can't use this again? What was that the reason for this? Very easy. I hope you know it. When we look the constructor, I provided a constructor, but this is not a default constructor, which means now I have to use this constructor here. All right, let's use it, which means we have not a default constructor, or I could make it a default constructor when I provide here a default value. We know this as well. Then I could use it as a default constructor and as a with a parameter constructor. So I could make them both, but let's say I have not a default constructor, which means I have to provide here to create this name indeed a name. All right, let's do this. And we know we can provide it in different ways, and let's provide it this time this way with this curly braces. And I write, for example, Maggie in. So this is one way how to create an object. So when I create this one, now I have this object with provided argument Maggie, which will be used here in this constructor, and it will be initialized here on top. So far, the normal way. This was not the normal way, that was the static, right? You can see we have not here an object. This is just using the class and it's calling directly the function without object name. And the reason for that is a static function is not connected to an object. It is just connected to a class, and this is also a very let's say, it is also a point which is irritating many programmer, because they say a class must be instantiated to be used, and this is a proof that's not so really true, because a class can be there and you can use it just with static functions. And that's why I say this is so an exception, so special function. That's not the normal case. But I hope till this point you know all what I talked about, because that was what we learned so far. But here we have something not really new, but it looks again strange. So what is that? Here we have here a function. This function is this function here, so a normal function call actually. But when we watch here this parameter again, and it starts with name. The name is our class, the type, and then we have here this curly braces, and this curly braces is more or less just a use case of the constructor, which means I have here a constructor. I could use here this curly brace, but also this round bracket. With other words, here I call the constructor. And what is so strange here is I have again no object. So this object was in both cases not provided, and it works. This is working without an object as well. And this one is not static, because, okay, static is not connected to an object that we learned, and we can call it. But what is that? Why is this working without an object? At least not with an object name. And that's the point. We have talked about this, something similar to this in functions. Let me show you what we made with function, which is similar to this one. And let me create here another function. Let me create here a function in my class. So because we want to learn a little bit more about class, right? This was a static function. Let's make a normal member function. Because right now you can see we have not a real member function here. This is not a member function. This is a static function, a special function. Now I make a normal member function. And one more point, of course, this object here which we created can call, let me show you this, oops, not that. This here can call, of course, the static function as well. We have here two ways to call this static function. I can call it with this object as well. Let me show you this. Paste in, access identifier and the static function. You can see it is anyhow treated here as a member function as well. So when you create an object, it is treated like a member function, but careful, like I said, static functions are special functions. They don't need an object. They are not connected to an object, but you can use this object later to call the static function as well. But you can see we don't need. That's just very important to distinguish this. Because the static function can cause problems as well if you use them wrong. And yeah, let's go on. Here, we was here with this version, which perhaps we already know, and let me show you what we know. So let me create here, for example, a function, a normal function. Let's make it a void member, and let's call this a member function, just because I don't know what to do with it. And look what I'm doing now with the parameters. We did something similar to this one here. but it looks only a little bit different than this, but it's almost identical. Look what I did. I just wrote here int. And let's make here another example. Instead of using here the definition, let's make just a declaration. And when you make here just a declaration, you see this green line here below, a little bit like waveforms, and that means all time you have, of course, to provide a definition. And if you make just a declaration, you can perhaps you can define it here directly, and like all time you can go outside as well. Let's make here an outside definition, so we repeat a little bit how to create all this kind of stuff. You just take here the declaration, and what's important here, because you want to define this one, you have of course use the name and this scope resolution operator to say where we can find this one, which means here in front I just write name, this colon, and we have it almost what we need. Of course we need here our definition, and now you can see the compiler is not complaining. And we talked about this one here, right? We talked about this one here. What is that? In this version here, I will show you one more version here in a moment, and I talk shortly about it. This is a this one is, by the way, also a class. This is just a primitive class, and here we are using not a primitive class, we are using here a user-defined class. You can see it's similar. That's why I said we already have talked a little bit about it. And so let's remember what was this case here with this class, but without an identifier. I called it there an identifier, right? We have no identifier, is just a name, a variable name. The point here is when you call this member function here, you have to provide an integer, but this integer has not an identifier, and because this identifier in this version, what I show you here in both places, there is no identifier, here's not an identifier, I can't use this provided integer, right? But that means not I can't use this call to do something. You can still do something with it. What you can do, for example, I can still do any action here what I want, which has nothing to do with this input here. Anything what you want, right? So the important thing is here, when you see something like that, it can be used in different ways, and let's say I can still use this function. The question is here, of course, hey, wait a minute, when you are not using this one here, this parameter, why the hell you are providing a function with a parameter? And you are absolutely right, that makes no sense. But let's say I made a strange example back then in one of my tutorials where I said, hey, I have here, it's also not the best use case, but it works. Let's say I have here 3 variables, and you can see I have now 3 variables, and overloading is allowed, but overloading is only allowed when you change here a little bit the signature, which means you have to change here parameters, or you make it const. This is also allowed, but normally you would change here these parameters. And I said, okay, let's distinguish them, and let's say I need only one integer here. Let's say I need indeed the first one. So let's change this to int number, for example, param. All right, now I have here int number param because I have to define this number param. So you can see this one is now this one, but these are, what is that what I'm making here? We talked about this as well, is this function overloading, and function overloading, like I said before, we need distinguish this one because this is not allowed. If I try now here to compile, you can see the compiler will complain, and it will say in here it is already decided, member function already defined. So, and then I said, okay, number param, and I throw in just a dummy value class which is not used. And this is one way to use, for example, not used name in parameters. We talked shortly about this. And yeah, now you can define this also outside. You can go here. You can say, okay, I just use the first param. This one is just to distinguish that. When you want call me, you still provide two integers, but I will use only the first one. It makes a little bit more sense than the first example, but also not that much. But it makes a little bit more sense. Okay, this will so go on, and of course you have again provide here this as a member, so we know we have defined this one. Let's skip this one, but you get the idea, right? So we can just provide here a class just to distinguish the signature. But actually there is one more use case, and you will see it. For example, again to this one, what I showed you not when I explained these examples here is sometimes you see a declaration like this, right? And this int here is still provided with a name in the definition. What I mean with that is you can see here we have this definition for that, right? In this example here, this int is not used when you use it this way. But let's say he provide this definition, this declaration here, and you still can provide in the definition a name for it to make it useful. Let me show you what I mean. Let's say this is just int random random param, and this random param is now connected to this function here, even I have not provided this variable name here, right? This is we have not talked about this, but you have to know that this is possible as well. So we have here a declaration. So with other words, I could even kick out both params here, both parameters, just type, and this one is still this one here. But here I have provided names, which means here I can use them. So let me show you this. So let's say I use this name param, which is an integer. Let's print them both out. It's easy. std cout number param here, and random param. Let's print both out, right? So let's see if this is really working or I'm just talking crap. Random param. All right. So I say that this function is connected to this function. I can call this here. Let's we have created here an object, right? We have created here an object, and I use this object to call this member function here. How I make this again? You just use the variable name like we learned, like we use a class name object. All right. I use the access specifier dot because this is not a pointer. And you can see I have now access to this one when this is public. Indeed, it is public. And that's why I can call it outside. And I call this one. Let's call this. And what was this called? Member function or static function? Oops. It was called member function, but you can see this name has the same name. This function here has the same name like this function here. And we talked already about it. This means we are dealing with overloaded functions, which means when I use here, not the static, when I click here on member functions, let's click here, you can see it says here +1 overload. So we know there are different versions of that. And now here we have this drop down. I can see this is one version which is just saying int num param. Okay, this is not what I want to call. Here is when I watch this one, interesting is it's already showing me the definition here. So in this case, it is not showing me that what I have declared here. This one here is just jumping to my definition and showing that you have to provide here two ints, and then you can use these names here. All right, that was that. And let's see, let's provide them to see if this is indeed working. Let's write here two numbers, because I need just two numbers. And let's comment this out, because I don't want now the other ones running. And let's see if this is working. And what we see is indeed I provided these two numbers and they are printed out like we expected. So that was that with this type without name, but we are not finished. What has this to do with this one? And uncomment, and when we watch now this here, that here, this one here, and this one here look similar, right? Because this one is just a primitive type, and this one is just a user-defined type with a constructor call, right? So I hope that makes sense, but what is important here to note is that what you have to think now is you will see sometimes some programmer will use this call here without providing an object name. Like here, I provide here nothing and it still can work. But important is here, this provided object name here is called an anonymous object, I think. And the reason for that is here in this function, let's go into this function, you can see we are providing an object, this name here. It has no an object name here at this point, but we are providing all the necessary information so that we can call this, use this parameter here. And important is that this object here is not saved before. So with other words, when I use this one here, I can use it in the function. You can see I can call the function and this function will do something with that. But this call here at this point was never saved as an object, which means later I can't do anything with this one here. Let me show you what I mean with that. Let's uncomment all the other things. Let's say I need only these two lines here. Uncomment the other ones. So this two. So let's use only this one, right? We are interested now in these two lines because here I create an object. I call this one, and this object let's call this one here also. Let's make this one here. Print name here. I call again, but this time I use an object name. You can see name object, this one. And here, of course, I don't need to provide this constructor like here, because here I already have used the constructor. So I just need here provide a object name, which is just a name here. This one, I provide that. And that's it. That works. But now when I compare this one to this version where we have not constructed this other, let's call here another name, for example. Let's call this here Wonder Woman, whatever. And now you can see this object Wonder Woman is never saved. It is just used here once. Then the function is using it here once, and then it is also destroyed at this point. What I mean with that is, yes, we can use it. Let's start here, this program. And then we see here some outputs. The first one is Maggie. The second one is Wonder Woman. So because that's the function calls here, function call 1, function call 2. And all the time when we call this function, it is used. But the problem is now when you go on in your program, you can use this object with Maggie. So this Maggie object you can use where we have name object here. And then you can do whatever you want again. But here, this one is again one of this object which was just created there and used at the same time where you, yeah, let's say where we called it, we created it, and then it is destroyed, right? So at this point, that's it normally. That's it. What you have to consider, that there are some objects which are just created at the point where they are used. And this is sometimes in many codes, sometimes they do this because they say, I'm not interested in this object name here. I don't want save a variable. I just want it used one time. And then they are doing something like that. They are just creating not a object variable. Yes, a variable. So they are not wasting more or less size to create this or whatever reason. They are just calling this object with the function, and that's it. So with other words, they try to shorten the code in their programming. They make it much shorter because they say, I need it only one time, and perhaps I don't need this object at all. And that's the reason why they don't create it at all. So here, the normal way is you create it, you use it, and here, no, I call it one time. I don't need to create an object name. I just use it, and that's it. And that is something what can also irritate many starters, because you can see this is again a more or less a special case, because this is not the normal use case, like I say, because normally what we do is, yes, we create an object, then we can use it wherever we want, and then we call it in a normal way, right? So normally you would just call it like this function. This is the, let's say, the easy call, but the shorter call is this line here. So when we compare now these two lines versus this one line, because if you use here an object, you may have now two lines. And if you say, I don't need to save this here, you have only one line. And they will, yes, they will use this technique in programming in many places where they want to avoid creating variables, where they say, I don't need this variable anywhere. I just create it one time and that's it. And if you understand this one and get to use that one here, that's something, this is possible, and don't get irritated by this structure here, which is irritating. But here a tip: when you see something strange all the time, hover your mouse over it, and then you will get here this information. And that's why I said it's very important that you get to use to read this tooltip. This tooltip is most time giving us the definition of whatever you hover it, and the definition here says, okay, whatever this one is, it is class name. And when you see here name, we learned it. What is this? This is a constructor call. Yes, it is calling a constructor which has a parameter which is a string. So this here is just a constructor call here. Something like that gives many informations. And yeah, this one is not a good information. Just hover here over this one and get to use it, as this is happening in many, in programming when they try to shorten the code. I hope it's not too difficult, right? So I think I stop here. That was this kind of stuff. And also read this again, of course, in good C++ books and in online documentation, why they are doing this. But most time to make the code shorter, because like I said, they don't want create variables, but then it looks a little bit strange. And then you have to understand this call here. And what I say, it's difficult sometimes. Sometimes we can call a constructor also with this round brackets. Yes, this is also allowed. And then we have, then looks again. This one looks again. What is that now? So you have to train this anyhow in codes when this comes up, that you, especially as a starter, that you not get irritated. But like I said, the best way at start is hover your mouse over it and try to read this one, or make it even easier, hover your mouse over it, right click, and then most time this one works. Go to definition and read whatever this is. Then you can see, okay, this one is connected, whatever this is connected to this one, and then you can see, oh, name, constructor, constructor call. Okay, this is just a constructor call without a name. All right, I think I talked much. It's not difficult to understand, but sometimes very irritating in code when they are using it. Get used to it and there will be no problem. So with that said, if you have any questions, any suggestions, anything else, write it in the comments, and see you in the next video. Good luck, have fun, and like all time, never give up. Bye.